Good evening. We're here to talk to you tonight about securely unlocking IoT for your enterprise with Azure Sphere. I'm Helena McMaster, and I have two Microsoft colleagues who'll join me tonight, Steve Patrick and Marcello Majanci, and we're also really excited to have Dan Apone from Starbucks join us. So let's jump right in. Microcontrollers are low-cost, single-chip computers. They're about the size of your thumbnail, and they're in virtually everything, from automobiles to appliances to medical devices to the escalators and the elevators in this building. When MCUs were introduced, they brought simple computing to these devices, but they weren't connected to the internet. And today, only about 1% of them are, but that's changing rapidly. Connected devices will change the way that we live and work in ways we can't fully imagine yet. We're seeing transformation already across many different industries, and that's because of the value that connectivity brings and the opportunity. You're able to get telemetry. You're able to understand feature usage patterns. You can offer your customers new capabilities, post-sales even, and new experiences like predictive maintenance. When we talk to customers, we typically find that they're completely sold on the value that they could gain, but they often haven't moved ahead because of the risks. Security is the big challenge and the concern, and a recent study showed that customers would pay 22% more on average for an IoT device if it were secure, and they'd buy 70% more devices if they were secure. Those are really big numbers, but that's not too surprising when you consider everything that could go wrong. You could have your device rendered useless, taken over and used for malicious purposes, loss of confidential data, data pollution. Imagine that you rely on devices around the world to run your business, and you come in one day and they're suddenly all bricked. Think about the logistics, the cost of rolling trucks to replace those devices all around the globe, the downtime that you'd have, the damage to your quality and to your brand that just one of these attacks could cause. Robust end-to-end security is the key to addressing these risks. And we've learned that in order to be highly secured, a connected device must have these 7 properties. These are actual properties. They're things that can be measured. They're not simply principles or intentions or aspirations. Our team's written a paper that describes each property in detail, and you can find it at aka.ms/WAC7properties. Some of the properties depend on hardware. For example, the hardware root of trust. Your device might pass through a wholesaler, a retailer, and other supply chain partners until it's finally installed. And once it's installed, it's going to connect back to your enterprise through your cloud. When that happens, there's a few things you will want to know. First, you'll want to know that that device has an identity and that it is actually your device and its identity hasn't been stolen. Second, when that device boots up, you'll want to know that it boots up with the software that you put on it and that it's not booting up with the software that somebody has since put on it, a hacker, for example. That's secure boot. And then third, when that device connects, you'll want to know that it's still running the software that you put on it and it's not running some other software, it hasn't been compromised. That's device attestation. All these depend on hardware. Some of the properties depend on hardware and software working together. Dynamic compartments are a great example. They prevent a breach from progressing. So it's analogous to the physical layers of security that you see here in the castle walls. And dynamic compartments require hardware that can create barriers, and then software that knows how to configure that hardware and create compartments. The two have to work hand in hand. Finally, some of the properties depend on hardware, software, and the cloud working together. Renewable security is a great example. This is the ability to update your device once your device is in the field because a vulnerability has emerged. We've learned that with software and with security, you're never really done. Hackers will invent new attacks and they will try to use them. So you have to have a cloud that knows how to provide updates. You have to have software on your device that knows how to robustly apply the updates, and you have to have hardware that can prevent a rollback attack. A rollback attack is when you have version 1 software running on your device and a vulnerability emerges. So you release version 2 to fix it, but you need to guard against hackers tricking your device into rolling back to version 1 and then attacking through that version 1 weakness. And in order to do that, you have to have some means in the hardware to guard against version 1 ever running again on that device. A blown fuse, for example. So this might all start to sound complicated, maybe scary, maybe even overwhelming. It is really hard to build a device that guards against all these risks on an ongoing basis. You have to have technical expertise that knows how to build and weave together all these components into a coherent, cohesive solution. You have to have security expertise that knows how to detect and respond to ongoing threats. And you have to have infrastructure and operational expertise to deliver and deploy updates globally and rapidly when you need to. The complexity and the challenge in addressing all of this is the problem that we're addressing with Azure Sphere. There are 3 components to Azure Sphere. First, we have our certified MCUs. This is an entirely new class of microcontrollers that we're working with our partners to create. And there are years of Microsoft learnings building highly secured devices that have gone into the IP block that is in every Azure Sphere chip. So there's Microsoft security technology built in. Second, we have our operating system. It's secured by and serviced by Microsoft. So we now have a trustworthy platform with secured hardware and software working together. And third, we have our security service. This service reaches out and it guards every Azure Sphere device that's out there. It uses certificate-based authentication for device-to-cloud communications. There are no passwords used in Azure Sphere because of the vulnerabilities that they present. It also monitors the entire ecosystem of Azure Sphere devices for emerging threats using online failure reporting. And finally, it provides the update mechanism and channel for both OS and application updates. So how do you implement Azure Sphere? What often comes to mind for folks is the greenfield, building into a new device, designing in, and you can absolutely do that. But there's also the brownfield. There are all these existing devices out there, and you might not be ready yet to update the equipment in your factory or your building or your retail environment. So we'll talk today about how you can get started right away in the brownfield with Azure Sphere. We're really excited about the growth in our hardware ecosystem. At the heart of every one of these options are the Azure Sphere certified MCUs. We have development kits that can help you get started prototyping. If you're building a new device, we have modules that can accelerate your time to market. And for the brownfield, we have Guardian modules powered by Azure Sphere. So I'm going to turn it over to my colleague Steve, who'll talk more about Guardian modules.
Thanks, Selena. So as Selena mentioned, brownfield scenarios include existing devices that may or may not have connectivity already built into them. At any rate, these devices may not be suitable to be directly connected to the internet. She mentioned the 7 security properties in the paper that we talked about, and I invite you to go review these 7 properties, look at your downstream devices that you want to connect up, and make that determination for yourselves. However, a Guardian module powered by Azure Sphere is meant to secure these downstream devices. So let's take a look at some capabilities and some scenarios where you would use a Guardian module. First of all, what is a Guardian module and what is it not? A Guardian module is not a gateway. So don't think of it as a network appliance you would hook up and shovel data through at the network layer to route to the internet. It does ingest data from the downstream device. It can perform some limited processing and filtering. And of course, it secures the downstream device by being in front of it as a connectivity service. For upstream communications, connectivity to the internet services, whether it's Azure IoT Central or other Azure IoT services, we support Wi-Fi and Ethernet today. And for downstream communication protocols and interfaces, we support a variety of things: UART, Modbus, Serial, SPI, et cetera. A couple of things to keep in mind as you go forward and look at what you want to use your Guardian module for. There are very limited resources for storing data and for processing data. So don't think of this as a full-blown Azure IoT edge device that has a rich set of capabilities for things like cognitive services. You definitely would need something larger than what we've got for that. In addition, it has limited storage. So as you look at your downstream device and you're thinking of, well, what kind of data am I going to push and pull from the internet? You really need to consider where that data is going to land, because for the Guardian module, for Azure Sphere today, there's limited storage on the device. So here's an example of, let's see if this works. I don't know if you can see the laser dot, so I'll just point them out. Here's an example of a Guardian module today. So you can see you have the Azure Sphere MCU on there, and if you look closely, it's attached to an ABNet module. Helena mentioned this in her previous slide about the ecosystem. For downstream interfacing, we have Ethernet, so this is the interface that would actually connect up to your downstream device, whether that's a toaster or whatever you're connecting to. You have some external LED indicators, and you might want to consider doing something like this, pulling those indicators out to the external enclosure so that the operator has some idea of Wi-Fi status, power status, other status indicators that you might want to bring out to them. This particular one is powered by USB, and it's got an FTDI chip for onboard management as it goes to the factory for provisioning and whatnot. So let's take a little bit closer look at a communication flow between a Guardian module powered by Azure Sphere and the Azure Sphere security services. So you can see down in the bottom left corner there, we've got a brownfield device, some existing device or equipment. We've got the Azure Sphere, the Guardian module there powered by Azure Sphere. And up top, we have the Azure Sphere security services and Azure IoT services, in this case, Azure IoT Central. So when an Azure Sphere device boots up, one of the first things it does, and you can see in this green line there, one of the first things it does is it's going to check for application and OS updates. So if there's any operating system updates that have been released, it's going to look for those. It's also going to look for applications that the customer has configured, maybe V1 to V2 for over-the-air updates. As part of this process, the very first thing it does is authenticates to the Azure Sphere services, and then it performs what's called remote attestation. I'll talk more about that here in a little bit. But in the happy path where everything works, attestation is successful, authentication of the device is successful, what happens is the device will get a certificate. If you guys are familiar with PKI or certificate authorities, it'll get a standard certificate for client server or client auth from the Azure Sphere security services to the Guardian module. And it can use that for subsequent authentication to IoT Central, for example. So let's talk a little bit more about an area that I was talking about here previously, authentication and attestation. As Helena mentioned, one of the key problem areas for IoT devices are username and passwords. And I'm not just saying weak username and passwords, I'm saying any username and password. If you guys are familiar with the Mirai botnet, it made news a couple years back. It's still making news. Its primary attack vector is through username and passwords. So Azure Sphere has gotten rid of all of that. There are no passwords used to authenticate to the device. And as I mentioned in the previous slide, it leverages the Azure Sphere security services in order to enable what I like to call high assurance certificate-based authentication. I say high assurance because as it goes through attestation and authentication with a service, there's a number of checks it goes through to make sure the device is not only genuine, but also trusted. So let's talk a little bit more about how remote attestation works. First of all, when a device connects up to the Azure Sphere security services, it's going to authenticate the device, and authentication to a device, or of a device, proves that device is a genuine Azure Sphere device. Genuine doesn't necessarily mean trusted though, right? So it could have been originally, let's say it's OS version 1, and it was genuine, it was signed as a genuine product, but over time, vulnerabilities are exposed. Over time, new operating system updates come out, and there could be a time where that particular version of the OS is no longer trusted. So attestation proves that it's still trusted. What happens during attestation? Helena mentioned the hardware root of trust. So within an Azure Sphere device, we have we'll call it a subcomponent called Pluton. And Pluton is our hardware root of trust. The hardware root of trust essentially takes a set of measurement data of the operating system, performs some hash mechanism on those, and signs it with the unique key to that one device. We don't share keys. There's no global secrets across all devices here. During attestation, it sends the data up to the Azure Sphere security services. The services verifies that its signature is correct for that one unique device, verifies that the measurements, and it looks at those measurements and says, hey, are these set of measurements still trusted? If yes, great, go ahead and go down the happy path, give them a certificate, et cetera. If not, go get an OS update. So let's take a little bit closer look at how Azure Sphere issues those certificates. If I can get this switching to work. Couple of key concepts I want to talk about. One second. We have something called an Azure Sphere tenant. So think of an Azure Sphere tenant as a logical grouping of devices. You might have a set of hardware, and you're going to group that and essentially collect those or claim those or assign those devices to an Azure Sphere tenant in order to manage those devices. And so here what I'm showing is I'm saying, hey, go select this particular tenant. So I pre-baked some stuff in here and saying, hey, I've got a tenant with this GUID, go select that tenant. When you install the Azure Sphere SDK, you get a number of different tools in here. One of these is our command line interface tool called Azure Sphere. When you create a tenant, and I'll go into some details behind the scenes, what actually happens when you create your tenant? When you create a tenant, what we actually do is we actually create a certificate authority to ensure that these devices are only issued certificates that are assigned to this particular tenant. So we have multi-tenancy concepts there where every particular tenant has its own individual CA, so you can't have devices getting CAs trusted from other chains. If you've ever managed certificate authorities, you realize kind of how complex this can be. And for Azure IoT devices, or in IoT devices in general, I think this is a great story here. You don't have to go ahead and provision these manually. You don't have to manage the life cycle here. So going down that path, let's take a look at the actual certificate authority for this particular tenant. So what we have here is a command that says, basically, I've already picked the tenant. Go download the, I didn't have it pre-done here, 1 second. Go download the certificate. So what's happening is when I'm authenticated through this command line interface, I'm actually authenticated with my Azure Active Directory account. So if we look at this certificate here really quick, I don't know if you can see that, but that GUID there is the same GUID that I put up here for the particular tenant GUID I had picked. Now, why is this useful? Where it actually comes into play is when you're authenticating to services. So let's take a look at IoT Central here. Within IoT Central, we've got this interface here, and you can see here, if you can read that, it says, the root or intermediate certificates shown below can be used to generate leaf or device certificates. So what does this really mean? What it's saying is, hey, upload a certificate authority cert to this interface, and devices that are issued certificates, so we'll call them device certificates, devices that are issued certificates from this particular CA can now authenticate to this IoT Central application. So let's go ahead and do that really quick. We're going to pick the CA cert that we just pulled down from the Azure Sphere Security Services. And we're done. No, it says needs verification. So why do we need verification here? We want to prove to IoT Central that we actually own that certificate authority. There needs to be some proof that, hey, this certificate authority is something that I actually can manage and control. So if we go in here, it's basically going to generate what's called a verification code. What it's asking for is it's saying, hey, prove that you have access to this CA by taking the verification code, generating a certificate with this unique verification code, and upload that to IoT Central for verification. So let's do that. It's going to generate a unique code here. We're going to take that. We're going to go back into our command line interface here, and we have a download verification certificate. We're going to put in that unique value there and generate a, I call it pop.cer or proof of possession certificate. So we're going to take that. Whoops. So it's checking, making sure that it's actually issued by the original CA certificate that I uploaded previously, and we can see now that the certificate's verified. So kind of an end-to-end there. looking at like how you can get rid of username and passwords to manage Azure Sphere devices, how certificates can be used to actually authenticate to services, and these certificates aren't certificates that you have to manage. They're automatically renewed on a regular basis from the Azure Sphere Security Service and the Azure operating system. I'm going to pop back here. All right. Okay, that's the interface I just showed. And I think at this point, I'm going to bring up Dan Apone from Starbucks. So I don't know if you guys saw the keynote the other day. If you did, there was a piece in there about Azure Sphere and Starbucks and the great partnership we've had. Dan's here to talk a little bit more about kind of the real world aspects of how that deployment went, and as well as their ongoing plans. So, all right.
Thank you, Steve.
Thanks, Jan.
Hello, everyone. I'm Dan Apone. I'm the engineering manager at Starbucks responsible for the IoT program on our connected equipment, our smart appliances. IoT can mean many things to many people. To our particular world that I'm in, it's the equipment on the counter at Starbucks and what data we can get from those and what recipes we can push to those machines. So in the world of Starbucks, all the IoT value kind of falls into two different buckets. One is ensuring high-quality product is delivered to our end customers, and the other is reducing machine maintenance costs and downtime. So talking about product quality, that would include things like pushing recipes to each one of the coffee machines. Every time we have a new coffee bean, it gets slightly different brewing parameters in the espresso machine or the brewed coffee machines. So we try to optimize our flavor for what that bean is supposed to deliver. When we talk about the ovens, for example, and each breakfast sandwich or muffin, each of those get different settings in the oven. So having a portfolio of connected equipment lets us customize each one of the recipes for whatever product is being produced. The product quality stuff doesn't just end there, it gets into a lot of operational behaviors of the store. So with the IoT and connected machines, we're going to be able to see if baristas are properly discarding espresso shots that fall out of spec, for example, as opposed to serving those to customers, which would not give the customer the proper product flavor that they should be getting. There's a lot of machine health over time, barista behaviors that affect machine health over time. So after a barista steams your milk for your latte, they're supposed to pulse the steam wand to blow the milk that had gotten up in the steam wand out of it. So with the connected machines, we are seeing how good the stores are at actually complying with that and helping store managers train their baristas better to improve the machine's health over time. On the maintenance side of things, we're seeing the ability to help technicians in the field remotely troubleshoot these coffee machines. These things are expensive. They're like 20 grand, and it's the most expensive object in the store. So if the machine is broken and the technicians have to come service it, they learn about the problem and realize the machine needs a new boiler, and inevitably they don't have a spare boiler in their truck, so they have to tell the store that it's on order and they'll be back in 3 days to install the new boiler. So that store has now had a down machine for 3 days, which does not make the baristas happy, and customers can't get the product they need, which makes the customers unhappy. And we've paid for 2 technician visits to go to that store to solve that problem. The remote troubleshooting should allow that technician to have the boiler in the truck on the first visit out to the store. So in our stores, we have all of these espresso machines, blenders, refrigerators, water filtration systems, ovens, all of this existing equipment. It's basically the exact scenario that the brownfield devices that Steve mentioned, connecting brownfield devices. So the Guardian module that was on screen a few minutes ago is what we're using to actually connect to these coffee machines. We have a new espresso machine rolling out to all our stores. That's kind of the lead program taking advantage of the IoT program. There are about 100 or 200 of these installed at the moment, and will be several thousand by the end of the year. The espresso machine in question here, sorry, I lost my place. So when we have So the espresso machine actually connects to the Guardian module with an Ethernet connection for data, and the espresso machine also supplies USB power, which is actually a common scenario for this existing industrial equipment. A lot of these manufacturers put Ethernet ports on their machines thinking they would be connected someday, not really totally sure how it would actually play out in the real world. And they usually all have USB ports because that's how you manually update the firmware or manually install new recipes on the machine. So the espresso machine or the coffee machine or the oven are all able to communicate to the Guardian module over Ethernet and power it over USB. But that's not the desired end state. When we have new products in development, we're trying to get these Sphere modules built into the equipment so that we don't have wires running around our store. That gets in the way of the baristas. It causes extra nightmares for our facilities department when they get unplugged. It's a much better long-term solution to have it integrated. But for now, we're dealing with connecting legacy equipment. So we've got these Guardian modules, which are going to be mounted under the counter right below the espresso machine. The Guardian module is joining a new Wi-Fi network we are launching in our stores, and it will have the ability to fall back and join the guest public Wi-Fi if, for whatever reason, the other network isn't up and running. And then the Guardian module securely sends the data into our Azure IoT cloud. So all the analysis, all the dashboards, all of these things are built in the Azure cloud platform. We have a close relationship with our Microsoft friends. When we originally started doing connected appliances, it was with a coffee machine called the Clover, which is what Starbucks stores use to brew reserve coffee for our customers today. And those machines have been connected since 2009, and they have been a physical hardwired Ethernet connection. What that decade or so of use has shown us is that there is great value to Starbucks by being able to push recipes to these machines and monitor error conditions in these machines. What it has also shown us is that it's too expensive to expect to be able to hardwire all the appliances in our stores. So for years, we've been looking for a Wi-Fi solution that has security, all the security boxes checked, as well as offering some sort of platform for managing these devices in the field. So when our Microsoft friends started talking to us last year about the Sphere platform, we were all ears and jumped in to make this stuff happen with them. But that's not to say it's easy, because IoT is actually really complicated in the real world, and there's a bunch of different reasons for that. Starting with thinking about how many college majors are called IoT, right? It involves a million different disciplines. There's the person who knows about the firmware running on the coffee machine, and the person who knows about Wi-Fi infrastructure, and the person who knows about the security concerns. And it's just the knowledge base is spread across a lot of different people and different academic backgrounds. And what that manifests itself in the corporate world is that all of these people live in different groups. Inside Starbucks, I'm probably working with 8 or so groups that funnel up to 5 different executives. And so working across all the teams, even though we're all working on the same project, we're all working toward the same end goal, it's just sometimes hard with inefficiencies or duplicative work, and it's just the nature of trying to get a big project done in the corporate world. Then all of the work outside of, once you get outside of the Starbucks view of it, you're dealing with an entire network of companies, right? Our Guardian modules is a partnership between Starbucks, Avnet, and Microsoft. And then we've got the whole fleet of Wi-Fi providers that we're using in our portfolio of stores, the Googles and CenturyLinks and internet providers of the world. And then I've got this portfolio of equipment run by several dozen, or sold by several dozen different companies around the world, most of which are not terribly savvy about software. So if you think about the refrigeration company, they're experts at refrigeration, but they probably don't have any software engineers on staff. And the espresso machine companies know a lot about brewing espresso, but they don't know about software either, because they're an espresso company, not a software company. And so when we show up with these companies and present them with the API spec for how their machine is supposed to communicate with our Guardian module, we get a range of answers from, that's easy, we'll have that done in a week and release a new build of firmware for the blender, all the way to, what are you even asking me, and you guys need to fund a software position at my company to even take on this work just to send a couple JSON strings across a wire. And it's a delightfully entertaining experience seeing the range of companies and their interest in playing along with this. But obviously, as a corporation the size of Starbucks, we buy a lot of equipment. So most of the ecosystem is generally interested in playing along with us here. And so if you've made it to the Starbucks exhibit up in the 4th floor of the convention center, you would have seen 2 coffee machines and then a dashboard put together in the IoT Central with the IoT Central toolset. And so that was done by a gentleman right here, Marcello. So I'd like to invite him up to talk about the world of IoT Central.
Thank you, Dan. Good afternoon, guys. So as Dan, in a wonderfully candid way, explained us, enterprises are really facing a lot of complexities when it turns to, embarking in this type of digital transformation journey. What really happens is that because of the complexities in terms of skill sets, investments, time, a lot of companies that are starting these journeys of digital transformation at some point get stuck. Get stuck because maybe the investment that they envision at the beginning, gets massively over budget. Get stuck because they realize that they don't have the skills in order to take home that type of project, or get stuck because they realize that they won't be able to get the product and get the ROI, the business results, out of the door in time. This is something that has been very well defined in a famous book by Geoffrey Moore called Crossing the Chasm. It's a book about innovation, and is a book that really defines what are the challenges of companies that really need to innovate. And so crossing the chasm is really a key point, and cutting down on the complexities that are related to IoT projects is really what can enable customers that are starting these digital transformation journeys to being able to be successful with that. This is why, as Microsoft, we announced, I think almost a year ago, that we would invest $5 billion in IoT. And the main goal and the main voice of investment of those $5 billion is actually to help our customers and partners to simplify their digital transformation journey. It means that we are building technology and services and products that would abstract most of the complexities of our modern IoT infrastructure by raising and making available only the capabilities that are needed in order to enable the creation of rich, modern, and powerful IoT applications. The product that best embodies this strategy of cutting the complexity, actually taking on the complexity ourselves with our cloud, with Azure, so that our partners, our customers don't have to, is a product that is called Azure IoT Central, which is the product that Dan was mentioning. So Azure IoT Central is our hosted IoT solution platform. So it means that it's based on the same IoT building blocks that you can use and leverage as Azure services, but it meshes it up together as a single service that provides global scale, automatic scalability, automatic disaster recovery, high availability, and a single SLA for the entirety of the services that are underneath. So effectively, you can get out of the box capabilities like device connectivity, device management, monitoring rules that are based on streaming data, the ability to map user roles and permissions, and to create rich experiences in terms of dashboards and automatic monitoring capabilities, really without having to deal with the underlying infrastructure. But since it's best shown that just talked about, what I would ask Steve to come on stage and do with me is actually show you how easy it is to take an Azure Sphere device from scratch, build the code that runs on the device, provision that device with the Sphere security service, and then connect it to Central and use IoT Central to customize an application and transform it into a real rich experience. Now, this is something that usually is a development that takes weeks, months. we will try to do it in 15 minutes. So we will cut some corners, and we'll have sometimes something that we get already baked out of the oven, but we'll try to do that. Steve, you want to start?
Salt Marcello. Okay. Give me 1 second here. Let's see. Wait, sorry. 6, right? Okay, great. Hey, guys, again. So I'm just going to show you kind of how simple it would be to hook something up from our Azure Sphere SDK into Azure IoT Central, as Marcello mentioned. So what I've got open already is just a default template. When you install the Azure Sphere SDK, you end up with a number of different kind of boilerplate samples here. And the one we're going to choose is the Azure IoT Hub sample. Behind the scenes, so he talked a little bit about Azure IoT Central as a hosted platform. You don't have to worry about managing the IoT Hub behind the scenes, but behind the scenes, Azure Central is an IoT Hub, and that's where we're kind of using this particular sample to kick it off. So one of the things when you go ahead and load up this sample is what we can do here is look at, sorry, my mouse would be better. Where is it? You know what? Hold on 1 second. Let's just open this one, fresh one. Okay, so there it is, right off the bat. And you can see here that what we've got is this overview section here. And in this overview section, again, this is kind of installed when you install the Azure Sphere SDK. You can look at the device that's currently connected to your dev machine. So in this case, I have this small dev kit here, which is hooked up. And you can see here that we have some information about it, the device ID, the Wi-Fi status, things like that. One of the other things that we have is this connected service wizard, and we're going to go ahead and run this also. And what I'm going to do is I'm going to pick just an existing IoT hub that I have, and we're going to modify that and show you guys how to hook it up to IoT Central. So in this case, what it's done is it's inserted a bunch of boilerplate code and some helper functions for Azure IoT Hub. And so what we're going to do is kind of modify this. Look at some of these functions. So one of the main messages here is send message to IoT Hub. So instead of sending hello from Azure IoT sample, what we're going to do is we're going to add some code in here, essentially simulating temperature and humidity. So I've just built in a couple of snippets here. And this is really simple. It's basically saying, hey, give us some random values for a temperature, some values for a humidity, and send this off in a key value pair to Azure IoT send message. So let's take a look at Azure IoT send message here really quick. All right, so in send message, it's pretty simple. You come in here with currently just a standard message payload. You're going to pass that into hub message, create from string, and then you're going to send that event off to your hub. Now, a couple of things I want to show you before we jump into this also. When I say you're going to send this off to the hub, Azure Sphere, and one of the things I didn't mention previously is Azure Sphere, by default, is pretty well locked down. So I'm going to show you what we call the application manifest here. I don't know if you guys can see that very well. Does it fly off the screen here? How's that? Better? Okay, so in here, we have a manifest for this particular application, and there's a bunch of things in here. By default, like I said, it's pretty locked down. In this particular example, we've opened up all these GPIOs, but by default, you have to define them specifically, explicitly, if you want to access them. The same for allowed connections, and then the same, well, device authentication in this case should be the tenant ID that we used previously when we hooked up that last example I gave you to Azure IoT Central. So I've got some pre-baked values here. I'm just going to take these, pop them in here. And what we've done is we've defined the connections to the hub that we're interested in, we're connected. We've predefined the device authentication tenant ID as the same one that we use, like I mentioned, for the certificate example I gave previously. The next thing we need to do is we need to make sure we have the correct scope ID for our Azure IoT Central application. So we're going to take this scope ID, and we're going to take this and pop this in here. So now we're going to connect up to the, we've enabled Azure Sphere to connect up to the correct endpoints. We know it's using the correct tenant. We have the correct scope ID for the application. And we're going to go back into the utilities. Oops, sorry. We're going to back in the utilities here and change up that send message function. So where was I? Okay, message payload. So again, I mentioned that IoT Central, when you define something like, hey, here's a temperature value or humidity value, you're going to define, hey, the temperature is 35 degrees or something like that. Humidity is 70%. So we're going to change this up to include or accommodate that key value pair that I mentioned previously. We're just going to comment this out. So all we're saying here is, hey, take this, take the key name and the value name, insert it into the message and create it from string, and then we're going to hand it off down below here. We also need to modify our definition here, so let's do that. And let's change the, did I? Okay, let me go back there. Ah, thank you. Okay, so that's pretty much it. We should be able to build this. Let's see. Hopefully. Okay, and if everything works out nicely, it'll actually connect up to the Azure Sphere services. It'll actually pull down our certificate. It'll take that certificate. It'll use that to authenticate to the IoT Central services, and it will push up some data to the services. So let's see. Always a little dicey. So while that's going, under the covers, what I didn't tell you is that the Azure Sphere SDK automatically includes all of the Azure IoT C SDK, so that's all bundled in here. So what we're really leveraging under the covers here is the Azure IoT C SDK, if you guys have used that at all. Okay, so we should be able to, ta-da, send some data up there. And looks like it worked. Let's check our application. So within here, what we're going to do is we're going to look at this specific device in Device Explorer. We have this particular Guardian module example for the device I've got. And yay, we have a data point. So within there, we have just a few easy steps to just get yourself up and running. Yeah, it worked. To hook up to IoT Central. I'm going to hand it back to Marcello here. He's going to show you some more advanced scenarios of how you can configure IoT Central.
Thank you, Steve. So the demo gods are on our side today. So we cleared in just a few minutes the first big rock, right? Which is, getting a device, which is, a vanilla device, and, build a code, deploy on the device, and get it connected and sending, data to the cloud. Now, at this point, what we can do with IoT Central is start to turn, this device that right now just, shows some, measurement on chart to something that is meaning for us, is really turning the raw data that we're getting to this device, from this device, into actionable insights that can drive, a rich application. And in order to do this, IoT Central provides us with a bunch of capabilities that, again, are abstracting the underlying services so that we can take advantage of those without having to deal with the services themselves. So when we create an IoT Central application, we have a bunch of, these capabilities. We have the capabilities to explore the devices. So you saw how the device, was by Steve automatically provisioned and enrolled, and that automatically showed shows up inside IoT Central. We have the capability of group devices with basically queries, dynamic queries that we call device sets, in order to create fleets of devices, in order to then use the data coming from those devices to run analytics, to do device management, and so on and so forth. We have the ability to do analytics, so to use device set and run time series queries in order to find anomalies, to run jobs, which is effectively the ability to run remote commands or orchestrate a series of configuration updates and commands on those devices. Think as an example, performing a firmware update or a configuration update on the device. And then we have the ability to modified what we see and the behavior of those devices with a WYSIWYG environment that is directly embedded inside the IoT Central application. And for each device, we define a specific device template, which is effectively represent the schema of the device, which is the combination of the schema of the data that we expect to track from that device, and also the schema of all the additional information that we relate to that specific device. The metadata, the behavior, so the rule and the automatic monitoring rules that we run, and also the dashboard, which is the ability to create and templatize compelling visualization for data. So as you see, over here we have a bunch of telemetry data points that are the ones that were defined in the code by Steve. Then we can define specific specific settings, which is configuration that we can send back to the device. We can track metadata about this device, and those can be metadata that we store directly on the cloud or metadata that we want the device to be able to update. The ability to run commands, think about methods that we can call on the cloud and run down on the device. Monitoring rules, which is effectively the ability to monitor conditions based on the telemetry, so based on the payloads that we are getting from the device in order to trigger specific behaviors inside or outside IoT Central. And then the ability to create compelling dashboards. Now, it takes only just a few minutes to do this, but in order to save a little bit of time, I have an example of a similar template that I did starting from the same starting point as this, but giving it the flavor of what a real device powered by an Azure Sphere, an Azure Sphere board will actually look like. So I go back to device template. As you see, in addition to the Guardian module, I just created a fake power generator. This power generator, as you can see, has the same temperature and humidity as the Guardian module, but also added additional type of data that we are tracking, imagining that this device could have accelerometers, gyros, magnetometers, for example, the ability to define states, and the ability for the device to send specific events that we can track and map to specific behaviors. There, in terms of settings, we just defined a bunch of commands, a bunch of configurations that can be related to a power generator, like the speed of the cooling fan. Properties, those are the metadata that you can expect from an industrial machine, so tracking what is the model, what is the serial number, when it was installed, who are the people that are in charge of maintaining it, so on and so forth. Commands, the example is a firmware update process that we can trigger from here. Monitoring rules, this is interesting. Here I have an example of a monitoring rule. Very simple, so a monitor alert. So I'm constantly monitoring the payload for the temperature data values that are coming, and I'm basically running each payload that I'm getting against a very simple condition. In this case, I'm monitoring that the value is greater than a specific number, an integer, 100 in this case. And at this point, what I can do, and I have a visual representation of my rule with the data that we are getting from this device. I can trigger specific actions either inside the products, which is sending an email notification or calling a webhook, or even outside the product. And we have first-party integration with some major Azure services that we're sure you will recognize, from Azure Functions to Azure Logic Apps, Azure Monitor Action Groups, and Microsoft Flow. Now, Flow is particularly interesting, especially because we have a Flow connector, which is whose whose authoring is actually integrated in the UI of IoT Central. So you will be able to define your Microsoft Flow directly from here. And we also have templates that you can start with, but also you can start from scratch. And actually, in the Flow catalog of action, you will have IoT Central specific actions and triggers. An example, we have templates to trigger specific action in Microsoft Dynamics, in Teams, notification in the Flow apps, SMS with our partner Twilio, emails from Outlook. But also we can start with a sort of a blank template that will enable us to kind of take a look at what we can do to Flow. Now, I don't want to give you a full Flow demo. That's a different session. But just to give you an idea, I just log in with my Microsoft account, and I have my template. And as you can see now, it's loading the data of the application that is triggering the Flow, which is this build application, and this is the rule that is triggering. And then I simply add a new step, and from here I can tap into the vast catalog of actions that Flow is providing. So something super simple, like creating a new SMS, a new notification in Flow, like a mobile notification. And then from here, now, the type of metadata that I can define in a notification are limited, but the interesting part is that for each event that is triggered by a rule, I pass a payload that contains all the metadata that belong to that device that triggered the rule, and I can use that as a payload, and can I use to create a rich notification in this case. So I can put in a notification what was the device ID that triggered the notification itself, what was the value, and so on and so forth. To give you another idea of an example, going back, creating a simple notification email, here, as you can see, we are already showing a template of the email that we will be sending out. And as you can see here, we have all the metadata in the email about the device type, the device name, the rule, and the value and the notes that were triggered by this rule. Last but not least, dashboard. So the ability to use all the data and the metadata related to this specific device in order to create a rich experience for the users that will be logging in. And here is a typical, what you see is what you get, dashboard that I can compose with a library of widgets, and the creation of these widgets that I can choose from a library of different types, depending on the data type and the nature of data that I want to display, is super simple. So I just select, a new widget that I will find, over here. I give it a name. I define the time range, which is basically defining the query that I want to do on the time series data that I have in IoT Central, let's say the past 30 minutes. I define what are the measurements that I want to display in this chart. Let's say that I want the temperature and humidity. I just save it, and all automatically I get displayed all the data that I have over here. Now, in order to be able to have a rich experience. In IoT Central, even before connecting the Sphere device, I can leverage a simulator that enables me to create simulated devices in order to make sure that what I'm building, what I'm configuring in IoT Central actually makes sense. So in this case, I have already a simulated device over here. As you can see, there is simulated data coming in, both in terms of events and in terms of telemetry. And also the example of the dashboard that we just saw, this is how it looks with just simulated data that is coming in. As you can see, we can display time series data. We can display widget with values, with states, metadata, series of events tapping into an history, and different type of charts and data. As you can see over here, we also can display maps. Maps are the rendering of locations that are tracked in properties, so in metadata of the device. So if we go back here in the properties, we have a specific GPS location value. We will be use our corporate address, one Microsoft way, which is the Microsoft main campus. If I save it over here and I go back to the dashboard, you will see that now the map will be rendered and will actually show a location that is exactly the location of the campus in Redmond. Now this location can be just a metadata track in the UI like here, but if I have maybe connected to one of the GPIOs a GPS, the device itself can track its location and can set this location that can be updated live in the device itself. I also have a bunch of other capabilities that I can leverage in order to create richer experiences or to extend the experience beyond IoT Central. One important thing is what we call continuous data export, which is basically the ability to create different types of profile to export data targeting different Azure services. I have the ability to dump data into an Azure Blob storage if I just want to keep it for long-term storage. I can also send data to Azure Data Lake ADLS Gen 2. But also if I want near real-time and real-time data, I can just hook it up to an event hub of my choice or a service bus, and I will just be able to stream the data from all the devices that I will have connected seamlessly to that specific application. And the configuration, again, is super easy. I just, with the same UI, I just define the parameters of my, export. I define what type of data that I want to export. I put the connection string of my event hub in this case, and I will just, hit save, and I will be all set. So this is just scratching the surface of everything that you can do with IoT Central. And it's worth mentioning as a last thing is that all the capabilities that I showed here and also the other capabilities that I didn't have time to show are just what we expose. So every single capability maps into a specific Azure service that is part of IoT Central, but is a service that you don't have to manage. It's part of the product, which means that if you connect one device, we will scale that service and all the other services in order to manage the data and handle one device. If you decide whenever you want to connect 1 million, 2 million, 10 million devices, the whole infrastructure, the whole service is going to scale to provide all the proper size of services that you actually need for that device. And also the pricing is an abstraction, so you don't pay for the services that are underneath. You just pay a single bill for IoT Central as a product. And this is about IoT Central. It's a great combination with Sphere. It's an end-to-end story for security and IoT enablement without having to deal with most of the complexities of IoT. So thank you for today. We will remain here and also with Alina and Dan for your questions. I invite you to get a Sphere dev kit, open up IoT Central, spin up your own application. It's actually free for up to 5 devices, and just try it out yourself. Thank you so much. Yeah, if you can go to the microphone. If you guys have questions, you can use the microphones over here. If you can just form a line.
My question was just in regards to the marketplace that you guys have for certified devices that I saw earlier, and if there would be something. So we have a lot of BLE devices that connect to a central gateway to connect to the cloud, and I'm looking at this and thinking, well, maybe we could do more purchase solution rather than having to build everything ourselves. But we'd have to have the capability of connecting to the BLE relay and being able to firmware update of the downstream devices which are BLE connected. So my question was just, is there something already in existence that you guys know of that would do that functionality? This
is maybe less related to Sphere, but you have SDKs they go even beyond Sphere that will enable you to do to use a phone device as a gateway and being able to connect those BLE devices and being able to manage them seamlessly.
And there is I don't know if you saw in the convention center, there is a module by USI, I believe, that has BLE built into it.
Okay.
So you could start with that.
Thanks.
Hi. Why didn't you use an IoT edge device instead of the Guardian module? Why did you choose the Guardian module instead of like an IoT edge device for this?
So is the question, why would I not use an IoT device? Or?
Why didn't you use an IoT edge device?
You actually use an Azure Sphere device in this case.
So the Guardian module, that's the Azure Sphere was put in the Guardian module.
In the Guardian module.
So what does the Guardian module provide? What does it provide that?
Our Guardian module is more of a kind of a concept or deployment method. Like if you have brownfield devices. If you have existing hardware, you don't want to buy new hardware that has all this embedded IoT. You want to utilize what you already have. You could hook up an external module, so we call it a Guardian module, up to it. Guardian modules are powered by Azure Sphere. So the dev kit that I'm showing is also powered by Azure Sphere, right? The Azure Sphere is the MCU, the chip on there, the 36.
So there's no extra like compute or
There's no extra
on the
compute,
Guardian module.
correct.
Everything is on the Sphere.
Correct.
Hi. Any hope for DigiCert or Sectigo PKI managed chains being integrated with Azure Sphere down the line as opposed to Microsoft's?
Is the question, can I use essentially external CA chains to authenticate, or on the device to authenticate to other services?
Or just an Azure Sphere in general
Azure Sphere.
instead of the Microsoft one?
There's no plans right now. I think what you're asking is if I could somehow integrate my existing chain or a different chain into Azure Sphere Security Services into my tenant, and then when the device connects, pull from your existing chain.
Correct, because we have corporate policies for.
Yeah. Currently, no.
Okay.
No, but that's good feedback. Love to talk to you afterwards.
Perfect. Yep.
Really quick question. Any chance of adding reclaiming a device or moving a device?
Yeah, so reclaiming device or moving the device. We get that feedback a lot, especially in the dev kits as you're moving them between developers and things. We're working on something for that. I think we hear that a lot. It's, currently, we don't have anything to change that right now. Sorry. Plans, we're thinking about how we can do it securely. So I think the real challenge here is how do you identify a dev kit device versus a production device? Because in a production device, you certainly wouldn't want to be able to reclaim it to different tenants, right? So that's the challenge we're kind of working through right now.
Azure Sphere is a lot about the 7 properties, and I guess when in one of the earlier slides you said it's Azure Sphere certified MCUs. It's about the verification that these properties are there. If you go into an industrial security space, customers typically very quickly are interested how strong is the security claim. Is there any documentation how much protection the actual solution provides? Like, for example, is it a protection against SPAs, DPA, side channel attacks, fault attacks, this kind of stuff? And in good practice in the security business is then, first of all, that you define your security goal, and then you subject it to an evaluation that eventually proves that you have not made any fault in the implementation, so that as a customer you really get what you think you get. Is that part of the certification program, or?
That's a great question. I can't answer that, but if you stick around, I think we have some folks who might be able to help you on that question around, like, kind of what does it mean to be an Azure Sphere certified MCU, or I think another way to ask that question, maybe to solve what you're thinking is, like, are there other certifications that we're looking to comply with, like FIPS, for example, or something like that, that would help in that, to sell that story? Is that? Yeah, stick around. I think we've got some folks up front. You might want to talk to them.
He was also asking about documented case studies of the security outcomes.
Yeah. Does there a security target exist? Yeah. A documentation about security?
Documented security targets and how they're being mitigated. I think that's what he's looking for, is basically literature.
We've been doing some work to articulate the various attack vectors that we protect against, and then the mitigations that we have in place. If you want, we don't have it published, but it's something we've been working on. So
I'd be curious, yeah.
I talked to Josh about this earlier, but I'm going to mention it again. The underlying assumption here is that you have a high-speed network available. There are a lot of devices that need cellular connectivity. And when you go with cellular connectivity, there are a lot of underlying issues you need to take care of. Batching data, compressing data. It's a lot more expensive. You need integration with cell phone providers so you can get billing information. And there's just a lot of other stuff there. So we really need a solution that integrates all these capabilities into a cell phone network-based solution.
Yep. No, agreed. I think we've heard that feedback before, and we're definitely investigating that as a future connectivity option.
Hi, I have 2 questions. One is around Azure Sphere. So let's say if we have a setup or where we have an IoT edge device, and so where would this, which is not doesn't have Azure Sphere built in, so where would this Guardian module sit? Would it sit on the device side, or would it sit on the internet side?
Yeah, so if I understand the question right, so say you have an IoT edge server and you have this concept of a Guardian module, Azure Sphere, where does it play in this space? So Azure Sphere or Guardian modules powered by Azure Sphere wouldn't serve as the actual IoT edge device. These are very constrained devices. They don't have the power to run a container, for example, for IoT edge modules. So the way you would look at this is you would look at the Guardian module connected to your brownfield device as a downstream device to the IoT edge server.
Okay.
Connecting through the IoT edge server, processing cognitive services or whatever, and then sending that out.
So it means that if I have 100 different devices, brownfield devices connecting to my IoT edge, then would I need 100 different Guardian modules to be hooked up?
Yes.
Okay. All right. And the second question is around IoT Central. You mentioned earlier that there is a cost associated to purchasing the IoT Central, right, as opposed to underlying cost. So if I'm doing something like a proof of technology for a client and they just want to hook up few devices, do you have any package that would?
Yeah. Yeah. So IoT Central as a free SKU is a sort of a freemium model. It's free up to 5 devices, and then you start paying up to the 6.
And how do we define a device? Because there could be cases where we have one device which is serving other 5 devices downstream.
It's whatever makes sense for you, in the sense that whatever for you as the identity of a device, whatever comes with an ID, which comes with a single dedicated authentication, that's the device for you. Of course, you can mash up multiple physical devices into what you call a device, but it's up to you.
Okay, thank you.
Cool. Thank you so much, guys. Really appreciate it.
Thank you.